So hi everyone. I'll start by saying welcome to Sprint 3 of our Tokenizer series. I'm going to apologize in advance because I think I'm biting off way more than I can chew in this session. And the chances of disaster are very high. But I'm going to be brave and soldier on nonetheless. This session has a deck with a bunch of resources that you can follow along. That's the URL for it, so if you want to jump on that URL or that QR code, it's quite important because there's going to be a series of links and resources that you're going to need for the session. My goal for this sprint is to learn how to develop reliable AI agent workflows that produce valuable artifacts. I suppose the two key things here are reliable and valuable. I find myself when I'm working on this stuff now that actually one of the hardest things is actually just to sort of sit down and think about what in fact do you do every day? What is your actual work? And to sort of boil that down into sort of trying to sketch out what is the workflow that I do and what is the ultimate artifact that I produce is sometimes the biggest and most challenging part, because once you've done that, I think you can then work backwards from that and start to figure out how we can really use AI to help us with this. So that's the goal: reliable and valuable artifacts. Artifacts in this context are everything from, what I believe are the things that kind of make the business world go round: proposals, invoices, project plans, business plans, product backlogs, all the various updates and messages and so forth that we need to send. That's kind of what I consider to be an artifact. And valuable, means that it's something that we can use, that requires very little additional intervention for it to be useful. And hopefully, the more ambitious part of this is producing artifacts that, frankly, we're not able to produce on our own, not within a reasonable time frame and at a reasonable cost. So can we produce new valuable artifacts, reports, lead magnets, all those sorts of things that currently we've needed whole teams to do for us? So I'm going to start off with a bit of an intro to context engineering, which is, I would say an evolution over the 3 sprints that we've been doing here. We started off with a big focus on prompt engineering, and I think things have moved so fast over the last 5 or 6 months that, there's an emerging field called context engineering, which is the broader theme of this entire sprint. I'll talk about that in a bit of detail. And then I want to get into the weeds with agents and tools, workflow platforms. So someone that I think is really worth following, we always talk about swimming upstream to find people who can help you make sense of what's happening in the world. And someone who can help you make sense of what's happening in the world of AI is Toby Lutke, the CEO of Shopify. You can follow him on X, but there's an absolutely fantastic post that came out this morning that I highly recommend reading, by First Round Capital, which is a sort of interview with a bunch of Shopify people and how they are implementing AI, both sort of personally in terms of their own productivity and at the company. Highly recommend reading that, and keep an eye on Toby. He's I think an excellent sense maker in the AI space, particularly as it pertains to sort of adopting it in an organization. So that's Toby. Context engineering. I'm going to do a little bit of a recap here and fly through stuff that I think a lot of you know, but a lot of the newer people won't necessarily have gone through this in any sort of detail. I'm going to start with a quick sort of basic here of what happens when we type something into ChatGPT. Some of you will see this is a fantastic resource. I should add it to the slide deck, I will. But what this basically shows us is that in this section here, I'm going to sort of put together a little chat I'm going to say, what is the capital of Australia? And then I'm going to add an assisted message. What I'm really trying to show everyone there is that the whole sort of crux of using LLMs, using the chatbots that we now use every single day, ChatGPT, Claude, etc. What's going on under the hood, of course, is that the inputs that we provide are being turned into tokens. Tokens can be represented or are represented in numeric format. And at the end of the day, a large language model is a predictive engine that has an incredibly smart neural network trained on the entire contents of the internet, and its job is to predict the next token. So what we see here is a sort of sequence of messages, and this last message, which I typed in manually, but normally would be the predicted, the token prediction, is basically taking this sequence of numbers, and for each new number, each new token, is feeding this entire sequence in and giving us the next token, which is why it's called next token prediction. So that is the sort of heart of a large language model or how it works. And the reason for showing you this is it's obvious that in order to get good numerical predictions out the other end here, they're only as good as the tokens that get fed in before them. So this is why, sort of broadly, when we talk about context, context is all the stuff that we're going to feed into the LLM to get a good prediction. So making sure we give it the best sequence that we can is going to help us get good outcomes. Up until now, we've called that prompt engineering, but it's a lot more complex these days. Any questions on this sort of basic little demo of what's going on here? So words being turned into tokens, which are these, well, these are the tokens, which are then tokenized into these numerical sequences, which then are fed through the model and predict the next tokens. So the idea of context engineering is the art of providing the context for the task to be plausibly solvable by the LLM. And if you think about the sort of tasks that you do, beyond just sort of telling it you are a founder of a such and such a company, and we started in such a date, these are our products and services, we're going to have to give it other information in order for it to do useful tasks for us. That's all part and parcel of the context. And without that information, we're not going to get the good token prediction outcomes that we need. So we're moving from this sort of prompt engineering world where it was all about crafting clever instructions and sort of, craft the instructions, send it to the LLM, get the predicted response back. So now it's a whole environment. It's not just the instructions, it's memory, it's tools, it's retrieving stuff from different systems. Those things all feed in to the context that we're going to be providing to the LLM for it to then give us predicted outcomes that are not just answers, but also all the artifacts that we talk about. Just a quick recap on, in Sprint 1, what I talked about in terms of the sort of vision for how we can imagine knowledge work changing. Today this is us, this is the knowledge work. A lot of what we produce are these sort of artifacts, reports, emails, messages, proposals, presentations, and so forth. The sort of evolution. Currently we do that with our own tools on our computers. This is sort of knowledge work today, and the way it's sort of moving is that we're building these agents that have tools that can produce these valuable artifacts for us, and we're moving more into the role of orchestration, ideas, judgment, instructions, workflow curation, and so forth. So this is sort of the evolution over time, where we're moving one sort of layer up the org chart and relying on our agents, probably not going to be a single agent, but multiple agents that can produce these artifacts using tools that we traditionally have used. Okay, next concept I want to sort of build on when I talked about the next token prediction. As I just showed you there, when we type in something, it gets converted into those tokens. It then gets sent to the LLM. The LLM is then basically feeding these tokens in. For each of these tokens, it's feeding the entire sequence in and predicting the next token, which is why when you see those tokens spit out sort of word by word by word, what's happening is each time the previous context is being fed forward into this network to produce the next token. Pretty amazing. An exercise I often do in these workshops is I'll say, let's make up a little story. Okay, these 3 rows, you start with the word the. It's going to be a story about a dog that wants to go to the moon. The dog. The dog wants. The dog wants. The dog wants to. And you sort of keep going. And what's happening is each time you're feeding forward the entire sort of sequence of those words into the next token prediction, if you like, and each one of us is a token predictor in that sense to make up that story. So that's what's happening here. Each time we feed this whole context in, we get the next token, and that's the miracle of LLMs, is the fact that that model is so incredibly accurate at giving us plausible and a sort of valuable next token prediction. As we work through a chat in a sort of sequential, we put a message in, we get one back from the LLM, we put a message in, we start to fill this context window up. Up until now, that hasn't been too much of a big deal because all we've really relied on, up until recently, is the capabilities of the model in terms of its language ability and its general knowledge. But over time, we've started to add additional things to the context. So what happens is over time with these chats, of course, we fill up the context window. It starts to forget about things that we talked about earlier here because they fall out of the context window. Context window is finite. It's like, I guess computer memory. And as those tokens get added to the end of the token stream with new sort of conversational messages, obviously the older stuff starts to fall outside of the window. More recent techniques will do summarizing and so forth. So we'll try to summarize the earlier part of the context window so that we can keep some knowledge of it, but it starts to get fuzzier and fuzzier, which is why it's best practice, of course, to keep starting new chats when you have new ideas rather than continuing to sort of have very long chats where you discuss all sorts of different ideas that are unrelated. This, of course, the reason I'm saying this, a lot of you know this, but it also pertains to when you're coding. The longer a coding chat with a coding assistant, the more and more polluted the context is getting, the less and less reliable the token prediction is at the other end because we've thrown all this stuff in here and it's using every single token that gets predicted at the end here is feeding this entire thing in to each of those tokens. Pretty amazing, isn't it? Yeah.
Is it worth mentioning we're no longer talking about AI, but we're talking about the tool that now uses AI? So this part here is Cursor or the ChatGPT website or whatever tool you're using?
Yeah, so depending on the tool you're using, the tool is the thing that sort of constructs this context. At the moment, I'm really talking about the paradigm of using ChatGPT, but we'll get into the other tools in just a second. So with ChatGPT, but I would say for most tools, the challenge that we sort of have is this context is very precious and it's finite. And our broader objective here is to try to manage, to understand this firstly, and then think about how we manage the context so that we get good outcomes. That's what this entire kind of sprint is about. But then we're going to get into the meat and potatoes of what does that mean? Well, it means that we get valuable information from different systems. We bring them in. We organize our systems in such a way that they don't sort of, overstuff this with irrelevant context. That's all going to be part and parcel of what we go through.
Chris, can I just ask you, in terms of falling outside of the token memory, is that also in relationship to time? Like if it was a week later that I went and did something else in that same, say, chat, is that going to have the same impact as producing more and more tokens?
If you went back to that chat a week later, it'll be intact as it was. Yeah.
Okay, so it's only the addition of more context. Right. Okay.
So then, of course, we're starting to see these tools evolve. We're going from just using their sort of raw capabilities to starting to add before I talk about that, one thing that's sort of somewhat invisible, where we don't really see, we see what we put in when we have a chat, but one thing we don't necessarily see is there's a bunch of other stuff that gets injected into the context. So when we go into our ChatGPT custom settings, of course, as we've done in previous workshops, we've added our own custom instructions. ChatGPT over time is starting to build up a sort of memory database from various things that we've either asked it to or that it's automatically remembering. And all of that is also included, sort of pre-pandered to this context window in a way that you don't see. So not only is it the messages that we're putting in, also what's being fed into it, importantly, are other sort of invisible things that you don't necessarily see. This is of course valuable because if I start here and I say, when was the hub founded or when were we founded? Because of my custom instructions here, I've given it a whole bunch of tokens that talk about the digital hub, who I am, what my job is, etc. It's able to immediately predict an accurate answer here because it has this other context. Whereas if it didn't have this, if I didn't put my custom instructions in there and I asked it something about the hub, it would have no idea what I'm talking about. So, but the point that I'm making is that is also incorporated into this context window and is using up some of the context. All right. So then what's happened is our LLMs, at least in the AI assistants that we're commonly using on our desktops, ChatGPT, Claude, etc., have developed the capability to read files. More importantly, they've developed the capability to use tools. Okay, that's going to be the main focus of what we talk about today. And one of the very first tools that they were given was the ability to read files. So if you think back to ChatGPT, sort of fun to play with in the early days, then you could add a file to it. Wow, that was really where it started to become super valuable because now I could ground the answers in actual information that I could provide to it. So, of course, these days we've got a bunch of different ways of adding those files. We can connect to our Google Drive box, Dropbox, etc. A growing number of these connectors to bring in information from third-party systems where we store our data. And what's happening is the LLM has learned, because we've trained it how to use tools, that if we give it information or if we ask something that would probably benefit from this information, it's now smart enough to know that it has a tool called read files. And what it's able to do is when we give it PDFs, for example, or any sort of file, it then knows, oh, well, I've been given these files. I should probably use my read files tool. It's going to read that information that we've provided, and it's going to inject tokens from this into the token stream here. So when it gives us our answer is going to be based not just on what we've asked it, but also the information that we've provided. So these tokens are going to be predicted in a far more accurate way than if we just asked it something without the grounding. Does that make sense? That's sort of what's going on under the hood here when you add a file or add files. It's using a read files tool. It's taking information from the files that we give it, injecting those tokens into the token stream here, and then giving us our prediction here. So now it's not just language and general knowledge, it's also tool use. Of course, then we had web search, which is the next tool that it got. Now we can sort of toggle on this search the web. We can ask it something. It's smart enough these days to know, look, my training data cut off in April. This is a more recent thing. I'm going to use the web to search for it. And then what it's doing is, of course, it's going out, searching the web, sort of in a two-step process, getting search results, evaluating the search results, figuring out, are there ones here that we should actually go and get the content from that website, getting the content from those web pages, inserting it into the token stream here, so that when we ask it that question, it's going to give us an accurate information about, say, what was the name of the most recent cyclone or something like that, which it wouldn't know from its training data because that cut off, 3 or 4 months ago. But by using this web tool, we can inject tokens into the sequence here that have that valuable and accurate information. So now we're grounding our answers in web page content. The next tool, of course, that came along, and this is really mostly since we started this whole program, is the idea that we've trained these things to reason. We've fed them lots and lots and lots of examples of reasoning, things like mathematics tests where you have to show your working. So if you have to show the working, if you give an LLM enough examples of not just, here's the question, here's the answer, but here's the working that led to the answer, over time, trained on enough of that information, it can start to develop reasoning or thinking like patterns. And that's what we now have when we use models like O3 in ChatGPT, where we'll see that, we'll put a request in here in the form of a prompt. And before it answers us, you'll see it thinking, reasoning. It's generating a series of tokens here that appear to be like reasoning, that then help it produce these very accurate and improved token predictions out the other side. Does that make sense? What's going on under the hood there? So thinking or reasoning. And then, of course, we got this amazing tool. Does everyone, I presume, has played with DeepSearch? Pretty incredible capability that we have there. And really you see it using both its using reasoning, web search, and then the deep research is sort of this agentic process of understanding what the user wants, going and performing some searches, evaluating the information that we got. Does it meet the brief? No, we need more information. Sort of going through that process a number of times. Could be 10, 15 minutes, could include hundreds of searches, and then sort of performing citations where we link that back to the reliable information that we got and producing a report out the other end. And in that case, we're sort of grounding this deep research in what I love about it is the fact that it's cited, it's cited back to the original sources, which means, not only is the output sort of plausible and good, but we can always cross-check it because it links back to sort of the original sources. And then what we've seen more recently is these tools have added the ability to connect outwards to various systems. So ChatGPT now, and I mean, this is a moving feast. I could go there now, it's probably changed. ChatGPT now have a thing in the settings called connectors where you can connect into a dozen or so of the key SaaS platforms that tend to contain sort of valuable parts of your organizational data or personal data. And their limitation right now is that information is only being used in deep research. So what that means is if you start a chat with ChatGPT, you toggle on deep research, you have the option of including these, let's call them data repositories, in the deep research. So in other words, it's not just going to use web information, it's also going to use information from whichever ones you decide you want to incorporate. Now, the reason I'm pointing that out is it only uses those in deep research. It doesn't use those in sort of regular chat. So I can't just say, can you check my email and see the most recent email from Alex and please respond to him. It doesn't have that yet, but that will come soon. At the moment, these connectors basically allow you to incorporate that data into a deep research project. Claude, on the other hand, has been a bit more aggressive in incorporating or connecting out to third-party services that allow us to have sort of fully fledged AI assistant access to those platforms. So with Claude now, I can indeed connect my Gmail and say, please find the latest email from Alex and let him know, blah, 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 we'll set the meeting up next week. And have it do all of that, perform all of those different tool calls that are involved with finding the email from Alex, composing the new email, sending it, changing the calendar, etc. So this is where we start to get into this world of our agents are now, at least the ones that we're using sort of day to day, let's call them our sort of desktop AI assistants, are starting to reach out across the internet from just beyond the tools that they have, web search, deep research, etc., into tools that sit outside in these various systems, bringing in that information. But at the end of the day, what are they doing? They're still predicting the next token. So when we ask it to draft a reply for us, what it's going to do is it's going to make a call out to, it's going to know that we've connected the Gmail tool or the Gmail service. And in that service, there are going to be a search email read email, compose reply, etc. So let's just say there's half a dozen tools there. So when we give it that instruction, check the most recent email from Alex, draft a reply saying we'll catch up next week. It has to call a series of tools there in order to perform that agentic workflow. And in order to do that, all of those tools and the descriptions of all of those tools are also making their way into, if we go back to that context window, and I said, we've got our custom instructions, we've also got all of these tool descriptions that are making their way into that context window. All right. So the idea here, of course, is that from a context engineering perspective, we want to learn how we sort of orchestrate the knowledge that we have in our documents, in our databases, in our various third-party SaaS systems, the prompting and instructions that we've got to get good at giving to our agents. One thing I think that is missed a lot when we talk about this stuff are the stylistic hints about how we like to do things, how we like to write, how we like to compose our emails, how we like to draft our social media posts, etc. We need to also explain to it how we like to do that. And then finally, what tools are we going to give it so that it's able to do these things for us? Okay, enough yapping. Now, this is the part where almost anything can go wrong. So I have been working on a few little tools that I'm hoping will help us get hands-on and learn by doing rather than learn by sort of listening to me up the front here. The first tool that I've created that I'm hoping is going to work is a little tool that will allow you to get an Open Router API key. Now, what is an Open Router API key, and why have I provided this? Well, the reason is this, is that, for us to really be builders, and that's what we want people in this room to be builders. We don't just want to be users of ChatGPT. Fantastic, it's improved your personal productivity, but what we want is we want people to build products and services. And you're only going to be able to build products and services if you have a better grasp of what it's like to build with this technology. So the tools that I'm providing you with here and the resources are really in an effort to encourage more people to get to grips with how the tech works, experiment with it, develop some new skills, and develop the confidence to start building with it. Now, Open Router, let me give you a quick kind of tour through Open Router. So today, to work with a large language model, you sort of have a couple of different options. The one thing that you have to do is you have to integrate with an API. So if you want to, you can go and sign up with Anthropic, who are the providers of Claude, and you can get an account with them as a developer, get an API key and start talking to the Claude API and build little apps with that. Similarly, you can do that with OpenAI, go and sign up for a developer account with OpenAI, get API keys. You can do it with Google, go and get a Gemini API key, etc. The beauty of Open Router and why we've sort of said from day one, this is part of the recommended stack, is that Open Router have done the work of sort of bringing all of those models into one single environment where you're able to get access to the latest and greatest models and not be tied into one particular platform. So with a single account, we can go and use models from DeepSeek, Anthropic, Perplexity, etc., etc. And the truth of the matter is each of these models have different strengths and weaknesses. It's very nice to be able to say, I want this particular agent to use this model, I want this particular agent to use that model. Having that sort of level of sophistication is very, very handy. So this is the Open Router models page, and there are myriad models. Every day there are new models developed and made available through here. And in order to use Open Router as an API gateway, you generally have to create an account and put some money in and get an API key. And then over time, you'll as you make calls to that API, it's going to sort of reduce your credit until you run out of credit, you put more money in and so forth. So as part of encouraging everyone to want to do this and want to learn and want to play with this, we are granting everybody in the room $10 worth of OpenAI credits. And you're not going to have to go and sign up for an OpenAI account because I've built a little tool for you to get your own OpenAI, your own Open Router API key. And when you have that API key, we're going to use it in a series of exercises now. So let's start by clicking on this app here. And what this should, on this link, sorry, and what this should do is it should take you to a little app that looks like this. And the email address you're going to use here is the email address that I invited you to this workshop on. Please make sure you use that email address because that's pre-registered in the database. And if you didn't get an email from me, I'm going to have to do this manually for you, which is okay.
Are you talking about me? I've got my own key.
No, you've got your own key. But yeah, I'll have to do a little manual step there. But for the rest of you, you should be able to jump on this page, enter your email address, and you're going to get two things. You're not just going to get an Open Router key. You're also going to get a link to N8N. And I'll explain, because we'll get to that in a second step. But what you should receive is if you bang your last email address in here, click on Request API Key, it should pop up both an Open Router key that you can copy. Just hit the copy button on that. Ignore if a dialog pops up and says something. That should be copied to your clipboard. But you'll also see below that is an invite link. It'll say invite to N8N. Click on that and that should open up a separate tab in your browser. Okay, have a go at that and then let me walk around and help people. Okay, so the first resource that we're going to have a little play with is this one here called Agent Demo. So let's open that. And what I've built here for you guys is literally like a 101 on understanding how AI agents work under the hood. First thing to know is if you've never seen a Google Colab notebook, I would explain it as this. Google has Google Docs, Google Sheets, Google Slides. Google Docs is the cloud-based version of Word. Okay, so we used to use Microsoft Word on our computers. Google released Google Docs. Google Docs allowed us to basically, rather than using our own computers on our own Word, we could use their cloud and use Google Docs up there, and we could also make it available to collaborators. Google Colab notebooks are like, instead of coding on your computer and running it and getting everything set up on your computer to run the code, you can run the code on Google's cloud, thanks to them. They provide the compute and you can also collaborate on it. So I'm making this a Google Colab notebook, which you can think of just like a Google Doc, except this Google Doc is able to run code. So the first thing I want you to do is click on File at the top left there and save it to your drive. That means you've now got an editable copy of this. So it should say save a copy in Drive. And if it's saved a copy in Drive, then open that one, because then you can tinker with it and save it, and it's all yours to play with.
Sorry, Chris, I missed the original link to the
How did you get there?
Sorry to be back.
Okay, the original link was tinyurl.com
Cool.
/hubjoule23. And then if you scroll down a bit, you'll see this resources slide here, slide 36. and then agent demo. Now, the beautiful thing about Google Colab notebooks, and I highly recommend using them, and there are certain use cases where they're just absolutely fantastic, especially from a teaching perspective, because what you can do is you can intersperse documentation and code. So you can create these nice sort of sequential learning things when you're onboarding people or when you're wanting to teach something like this. So you'll see here each a Google Colab notebook, which is under the hood is a thing called a Jupyter Python notebook, is a series of cells. The cells can be documentation cells or they can be code cells. So you can see this is a documentation cell here where I've got some markdown text. And then each of the code cells you'll see has a little play button. And typically the way we do this is we sort of work sequentially through the workbook. So the very first thing we're going to do, if you haven't already done it, is you're going to click play up on this first cell here. And what that's going to do is it's going to install a few different Python packages into this Google Colab notebook or into a cloud container that Google are providing to us here. It's going to install the OpenAI client, which is going to allow our code to talk to Open Router, because Open Router uses the OpenAI SDK standard, as do all the LLMs these days. So they all sort of speak the same language. And then it's going to install another package for printing out sort of rich information for for educational purposes. So the first step, we click that play button and you should see a little green arrow, which means that it's successfully completed. Below a code cell, you'll see this little thing here where you can show or hide the output. I'm just going to hide that. The next thing we're going to do is we're going to paste our Open Router key in this cell here. So you're going to double click on the cell and you'll see where it says paste key here. And you're going to paste your key and it should end up looking something like this up top here. So paste that key. You'll see the next part of that cell allows us to define which model we want to use. Now, there are many models, as I explained. You can go and find them on the Open Router website, if you like. The one that we're using for this particular exercise is called GPT-4o Mini. Very inexpensive, great for learning, very reliable, very fast. And you can do lots of experimentation and it'll cost you fractions of a cent. So a good one to start with, but I encourage you over the next few days as you want to play with this and as you want to learn, go and substitute other models in here. And I'll show you in a second how to do that. Let's just quickly open up a new tab, if you like, called OpenRouter.ai. Let me put this in the resources section quickly for you. It's already there actually. You can click on this here and it'll take you to models page of Open Router, where you can see lots of different models here. The main ones are probably names that are familiar to you on the left-hand side here in a series. You've got the GPT models, the Claude models, the Gemini models, etc. So for example, if I wanted to, one of the latest models from OpenAI is this GPT 4.1 Mini. So all I need to do is just click on this little copy to clipboard icon here, go across to my model value there, paste that in, and now I'm using a different model. Yeah. If I make a change to a cell like that, I need to rerun it so that it reloads that particular change that I've made. Okay. So far we've got two cells. We've clicked the play button, and what we've effectively done is imported the packages that we need. And we've set some important information here. We've set our API key. Let me just get mine. Keys. Key. here. My key in here. And slide that again. So it's got my key. The next thing, and the sort of the main point that I'm going to try to make in talking about agents is an agent is effectively, you can think of it as a chatbot with tools. Okay? A chatbot without tools is just a chatbot. We can chat to it. It can give us information from its training data, but that's the limitation. It can't do anything else. For it to be an agent, it needs to have tools. And with an agent, we effectively give it two things. We give it tools to perform actions, and we also give it instructions and the autonomy to call those tools as it deems fit based on the task that we ask it to do. So in this exercise, we've got some simple Python code that is providing three different tools here. We've got a tool called getCurrentTime. All of these tools are what we call mock tools. They're not fully functioning tools. They're just there to demonstrate how the tool calling works, okay? So don't get too hung up about what's going on in this particular code. But you can see def getCurrentTime. So that's a function called currentTime. This is a function called calculate, which is going to perform basic mathematical calculations. And then there's a function called search where. And each one of these is basically stubbed out. getCurrentTime, we basically hard-coded a couple of values in here for time zone offsets. And this one here doesn't even have a search thing connected to it, but it doesn't matter for the purposes of demonstrating how an agent works. So we're going to click on this little play button here, and that's going to load up our functions. And then in step 3, I've got quite a comprehensive description of what's going on here. But one can think of this section here as the prompts that tell the LLM what these tools are and how they work. Okay? So this information here actually gets sent in the API call to the LLM, and what it does, as we can see, is that for each of those tools, getCurrentTime, calculate, and search where, there's a description. This description is effectively a prompt. It's saying to the LLM, I'm giving you a tool called getCurrentTime, and I'm saying to you that what this tool does is it gets the current time for a specific location. And in order to use this tool, you are going to have to pass in a parameter, and the parameter that you're going to have to pass in, you can see this is called parameters, is you're going to have to pass in this parameter called location. And for the parameter, I also describe this parameter, the location to get time for, e.g. London, Tokyo, UTC. These things are effectively prompts. It's very important that we use these fields when we describe our tools so that the LLM knows when and where to use these tools. And you can see here, to use this tool, this particular parameter is required. So if the LLM doesn't come back and say, I want to use this tool and the location equals London, if it doesn't give us location as a parameter, it's just not going to work. So that's required. Similar with calculate, the required parameter is expression, and the expression is basically a mathematical expression. Again, you can see the description here. That can be as long or short as you like it, as you need it to be. And all of these things are going into the context, right? They're going when we're talking to our chatbot and we're giving it a bunch of tools. Every message we send has this tools array going into the chat message. Okay, and this little workbook is going to show you how that happens. So let's load up the tools metadata. And you can see the output from that cell at the bottom there says the available tools are getCurrentTime, and it gives the description for each of those things. So if you were to change the description and you were to run that cell again, you'd see different available tool descriptions there. All right, now we get to the fun part. So this function here is basically a fully runnable agent loop. So what it's going to do is it defines some code that is going to take our prompt, add the tools, and send it to the LLM. So the important part I want to show you here is the messages array. So the messages array here, this is the system message, so you can see the system, so here's the messages array. Now messages array typically will have multiple of these. So you'll see, here's the first one, it's a system role, and the content is, you're a helpful assistant with access to tools, use them as needed to answer questions thoroughly. You can make multiple tool calls if needed to gather all the necessary information. So what that's doing is it's giving it the autonomy to make multiple calls as it deems fit, as it needs to, in order to achieve that task. And then the next message in the array is the user message. And the user message is the input here is the initial query, which is our little message, which is set earlier up here somewhere. So this is the really important bit. And what happens is those messages get sent to the LLM in an API call, and there's messages and tools, the tools array that we just went through, and all of this provides the LLM with context. It's basically one big prompt. Those messages, as well as the tools, are all a big prompt. So if we hit our little play button there, if we scroll down to the bottom of that,
Chris, would it help to contextualize what you've said there with your slide earlier, which showed the context sort of timeline almost? I mean, up to you.
Let's go through and then I can clarify if someone has a question. Okay, so now that we've loaded all those things up, we're going to test our agent for the first time. We're going to give it an actual query. So here's our query. We're going to say, what's 25 times 37? So let's hit this. You are making, for many of you, what will be your first API call with your own code. And what you should be seeing here is that this is just giving us a little bit of educational information about what's going on under the hood, mainly so we can learn about what's going on. So it's telling us that the message composition, what we sent to the LLM, consisted of a system message and a user message. So the total messages in context were 2. The context window usage was only 285 characters. And no tools were called. No tools were called? No tools were called because that was the starting state, okay? But then the LLM, so this is what we sent to the LLM, to the API. And then the LLM comes back to us, right? So let's see what's happened. So we asked it to calculate this 25 by 37. And you can see that what it's done is it has figured out that it needs to make a tool call. So it's requested a tool call. You can see each tool call has an ID. And the function that it's come back with is this tool call called calculate. And the parameters, also known as arguments that it's passed in, is the expression. Remember how we said we must pass back an expression, 25 times 37. And then our code has executed that tool. So these tools generally are sitting on our computer. They're not sitting up in the cloud as part of the LLM, right? So we're asking the LLM to decide what tool, but the tool's either running on our computer or, as we'll see later, is running on N8N or Zapier or elsewhere. But the important and amazing thing that it did there was it figured out from that, what's 25 times 37, it figured out that it should use a tool that we gave it. It didn't have to, it could have got that wrong. It could have guessed that, or it said, I'm not really sure what I should do, but it knew that it should use calculate, and it knew what parameters it should use. And once it gave us that back, our code was expecting this. Our code is expecting either calculate, search web, or get times, I forget what that one was. So our code, we have functions waiting for those things, sitting on our computer. And we're sort of listening for the LLM to come back, and if it calls a tool, our tools are ready to roll. So we got this, we performed the tool calculation, and what we then did, so now we have a system message, a user message, an assistant message, and a tool message, all in the context. And as the final step, what we did was, we then sent that as a second LLM call back to the LLM. Yeah, we sent that as a second LLM call back to the LLM, say that 25 multiplied by 37 is 925. So this is what we sent back to the LLM. And then it came back to us. It completed the task and it said, final answer, 25 multiplied by 37 is 925. So it gave us a natural language answer to the first thing that we asked. Is this making sense? You see what's going on?
And so Chris, you've created all of this.
How do you mean?
Like you've written all of this. This is not like, this doesn't come with, this is what you've created.
Yes, but I mean, there's not much to it. There's not a lot of code. There's nothing special about it. All I've done is I've defined 3 very simple functions, described what they each do. Think of the description of the tools as part of the prompt. It's telling it, hey, in fact, a nice way of thinking about this is, if you just went to ChatGPT, right, and you said, I want to make a souffle or something like that. And you said to it, at your disposal, you have the following things. You know, you have eggs, this. I want you to come back and provide the very specific steps for making that souffle. That's effectively what we're doing here, is we're saying to it, we want you to tell us, multiply these 2 numbers together, and we're giving you a series of tools here. One tool is a calculator, which you're obviously going to use to, you might get it wrong, but the likelihood is you're going to choose the calculator rather than searching the web to find that answer. Does that make sense?
Yeah, I think I go the other way. I understand it probably from my background at that level. It's the executional level, like looking at this going, wow, this is just a simple bit of coding. It looks
and I know that probably does feel a little bit overwhelming, which is why there's like a Google Colab notebook here with lots of documentation. Go home, play with it, fiddle with it. Let me show you the last bit here, which is, now let's test with a more complex query. Now what we're asking this thing to do, you're going to see the orchestration of multiple tools here. So we're going to say, I need to plan a meeting between Sydney and London. Can you tell me what the time is in both cities, calculate the time difference, and search for best practices for international meetings? Okay, so let's load this up. And then we're going to inspect what it's done. So let's go to the very end here and see what it's done. The final answer is the time in Sydney is approximately blah. The current time in London is that. The time difference is 11 hours. Regarding best practices for international meetings, here are some key tips. Schedule a meeting at a time that's reasonable, blah, blah, blah. Now, remember, we actually stubbed out the web search, so it didn't even really do a web search. It's just making up the web search results as it goes. But you can see what it did there. If we scroll back, you'll see it's orchestrated multiple different tool calls. So if we look here, we can see tool execution number 1. So it said, I want to get the current time, location Sydney, and current time, location London. So it made what's called parallel tool calls. It made two tool calls at the same time. And it got the 2 current times for Sydney and London. So this was our response. And then it used the math tool to subtract 12 from 1 to get the time difference. And once we had all that information, we sent it back. We basically said, this is what the tools have produced. Here's the information. Then the LLM's last step is to take what our tools have given it and basically give us back a nice clean answer using the data that our tools have given it. So it comes back and it gives us this nice answer at the end here. Now, if we want to get an X-ray view of the whole thing, click this last button here, and scroll down, and you can basically see the exact JSON, pretty much the exact JSON that was sent to the LLM. So this is a way for you to kind of understand what's going on under the hood here when we use agents, how they use tools, how all of that stuff makes its way into the context. Because each round, if we were to look at this output here, you would see that each round of messages gets sent, the whole thing gets sent each time. Remember how we said the token gets predicted, the entire sequence gets fed in. Every message we add and we send back is playing into the next token prediction, which is why, very long way of getting to the importance of context management. So just figuring out, building systems, approaches, processes that provide the LLMs, provide our agents with good context. So look, I'm not going to dwell too much further on that. That gives you, a nice little educational thing that you can play with to learn about. And of course, you can just jump into Cursor or anything and ask it to explain this to you, ask it to create your own versions of this if you want. But you now have an Open Router API key. You've got a Colab notebook where you can go and play with this. Colab notebook, by the way, is integrated with Gemini. So what's quite nice here is if you want to, you can just click on, let's just say here, I could click on a new cell. So I'll click on code and I can generate with AI. So I can ask this, I can click on this here and say, please do a version of this that does this, that, and the next thing. And Gemini will go and have a crack at doing that for me. Okay, Colab notebooks, Open Router key, how does an agent work under the covers? Hopefully, the main thing I wanted to show you there was how the tool calls, how we define the tool calls. The tool calls are just like prompts, the tool descriptions are just like prompts. Giving good prompt, good descriptions to those tools and how they work is a really, really important part of making sure these agents are effective. Okay, any questions from that?
Is it a bit of a less is more type approach to, like if you kind of have too many tools and too many runs, you start blowing through your context window and getting variable?
100% right. Yeah, so it increasingly looks to me like the best practice is to have, rather than one agent that has many, many, many different tools, which all sort of take up valuable context. Instead, what we have is an orchestrator agent who farms out jobs to the different AI agents to do their things, which is a pretty good segue for us to learn how to start doing that. So that was pretty techy. We're going to now, and Cody, we're going to go to a kind of no-code environment. So did everyone manage to get into N8N? So if we're in N8N, let me first just contextualize what we're doing with N8N. Okay, let me just sort of explain where this fits in. So my way of thinking at the moment is that we sort of have these different ways of triggering our agents to do things for us, and we do have different agent orchestration going on. So for developers are mostly using tools like this, either IDEs or command line interfaces like Claude Code, which these days are fully fledged AI agent orchestrators. For the rest of us that are not necessarily, working in those interfaces, we're using ChatGPT, Claude, and Gemini. And of those three, at the moment, Claude is probably the most effective agent orchestrator. What I'm trying to illustrate in this particular slide is that these desktop AI assistants that we're using these days generally ship with what I would call native tools and agents. The native tools that ChatGPT ships with these days are things like image generation, web search, Canvas, etc. Those are all tools that it is able to use. It also increasingly has a set of agents that it can use. So when you toggle on deep research, that's not just a tool. That really is a whole agent subsystem that it uses to go and perform deep research. But the point is that those things are all very much in the native ecosystem of those AI assistants. These tools, you don't have access to the code, you don't really know how they work. They just, and they only operate within this environment. So you can only really use those tools by invoking them from ChatGPT or Claude or Gemini. And if you're just going to do desktop work, it's able to go and use those tools and produce pretty valuable artifacts. I mean, there's no denying that, you know, some of these deep research reports that get produced are very valuable and you can do all sorts of cool things with them. But what we really want to do is we have a bunch of other tools and systems and so forth that we want our agents to get access to that are not just these things here, they are other things. So we have our orchestrator. We are generally working on sort of ad hoc tasks, and those tasks might involve those things that are native to those platforms, but they might involve other things. Might involve writing emails, running a report, analyzing data. So the good news is, since we started this whole program and today, there have been a couple of key evolutions, and one of them is a thing called MCP servers. MCP servers are emerging as a sort of bridge layer that bridges an AI assistant with third-party tools and services. So for example, writing emails that might sit in Outlook or Gmail or Apple Mail or whatever it might be, our AI assistants increasingly are able to use MCP servers that are provided by those SaaS companies, or sometimes open source, that expose the capabilities of those tools to our agents so that they can use them as they need to perform a certain task and produce a certain artifact. Now, what I'm finding sort of emerging as a pattern is that there are certain things, certain tools that might be super proprietary to me. They might be very opinionated and they might be very specific to ways that I want to do things. Those are things that I will generally code up in Cursor and make available on my computer as sort of discrete little tools, just like we saw there, you know, calculating time zones and all those sorts of things. Those will be tools that I have that I will expose so that agents can call those. But then the next thing is entire workflows that might involve a sort of step-by-step process of generating something from one system, feeding it into the next system, feeding it into the next system, etc. Which is where we're starting to use platforms like Zapier, N8N, other workflow platforms. And then finally, having not just sort of workflows, but having agents that we develop ourselves or that we have access to, that we can connect to from here, that will go and perform sort of whole agent work, whole agent activities to produce those artifacts out the other end. So this is kind of what's emerging as a bit of a, from my personal observation, is, you know, we're using these things on a day-to-day basis when we're working on tasks. We're using these tools a lot, but really to get best benefit out of this, we want to be able to connect into other tools out here as well. Okay, and that's where this idea of MCP servers comes in. And we're going to go to MCP servers and talk about them in length in the sprint, and we're going to develop one and we're going to use lots of them, etc. So we're not going to get too deeply into that today. But I want to introduce you to the next sort of concept, which is triggers. So when I think about working on desktop tasks here, my triggers are generally chat messages into my assistant. That's sort of triggering something. Please can you research such and such a thing. The trigger for that is me sending a chat message, almost always in that particular environment. Even with the IDEs, I'm sending chat messages or the coding tools, and that's sort of triggering the the downstream workflows. So triggers are a very important concept when it comes to thinking about workflows. And I want to sort of just introduce some thoughts about different kinds of triggers one can think about. So, the one that we're all sort of familiar with at the moment is triggered by me in chat. But increasingly, you'll see things that are triggered by a user message. For example, if someone comes to the Digital Hub website, types something into the chatbot, they may be needing a follow-up of some kind. I want that to trigger a customer service workflow. Similarly, somebody might type something into Slack, maybe it's a link, maybe it's something like that. That will be a user that isn't you, that is sending a message, that either you individually or you as a company are receiving, that is triggering a workflow. So that's a type of trigger. Another trigger is an event on my computer. That could be as simple as a file is added to a folder, but there are many other things sort of on your computer that I saw one yesterday, which is, Chris will love this, a particular USB drive gets plugged in, So the agent needs to go to work and basically prevent a whole lot of stuff from happening on the computer. So things that happen on your computer, triggered by ad hoc events in the cloud. So, increasingly this is emails received, messages received, a sign up on the website. Those are things that are not necessarily a user message or your message, but things that are happening across the systems that could be treated as triggers to trigger workflows. The next one is triggered by a scheduled event, or what we call a cron in tech, which is where we might say, we want this workflow to run once a day at such and such a time, or we want it to run hourly to check all of our social media accounts to see, have there been any comments on our posts or whatever it might be. And then the last one, which I think, is where there's a lot of interesting opportunity, but I haven't seen anything done with it really yet, is the idea that you might have agents that are sort of constantly monitoring all of these different things and proactively triggering workflows, not on a scheduled basis, but on some sort of qualitative assessment of what's going on in your world. So those are triggers, which gives us a chance to talk about another concept that some of you won't be familiar with, which is the idea of a webhook. So if the trigger is a chat on the customer service bot, or someone's filled out a form, or a ticket's been submitted, or in this instance a Slack message or an SMS, what we're able to do is we're able to connect our website, and increasingly we're able to connect up our messaging tools to these cloud-based workflow platforms by creating a webhook here. So basically what's going to happen is this webhook is a sort of address where the website or whichever app it is that we're using here can send a message, which then triggers this workflow. And this workflow can incorporate a whole agent or agentic sort of sub-workflow in here. Okay, so an example there might be, it might be a message from a customer, which triggers a webhook. We catch the webhook, meaning we're listening, we're waiting for any of these things to trigger a workflow. We catch the webhook, sent us a message. We then pass that into our agent. Our agent has tools like Airtable, Jira, Slack, and our prompt here might be, when you receive an email, unsubscription email, you need to update the Airtable. If it contains a complaint, you need to add it as an issue to Jira so that the dev team can follow that up. And then you need to notify the team that this has happened via Slack. Yeah. So that's just a very sort of, off the cuff kind of example of how an AI agent with a prompt might catch a webhook, call these various tools, and the valuable artifacts out the other end is, we've potentially automatically created an email back to the customer to say, please don't go. We've notified the team so they can jump on it, etc. I think another really cool one, Michael's working on something like this. I think when we're on the go, we're in a slightly different mode. We're not at computers churning stuff out, but we're increasingly going to want to have our team of agents in the cloud doing work for us while we're walking, while we're driving, while we're doing various things. I can see that happening via a mobile app. Of course, you know, the main chatbot AI assistants are all developing mobile apps that have voice capability, but you can also, you know, use WhatsApp, Telegram, etc., or create your own, where you're going to be able to issue voice instructions. Those voice instructions are going to get transcribed into text. They're going to trigger workflows here and get stuff done for you. So I think that's quite a cool, and for people with mobile sales forces, mobile workforces and so forth, I think this is going to be extremely powerful, is to put in their hands simple mobile tools that use voice, that take unstructured voice information, turn that into structured information and trigger valuable workflows here to do work without them having to go back, make notes, do a whole lot of desk work. And then of course scheduled, I think that goes without saying, you know, that's where you have a series of scheduled workflow tasks. Okay, so I think let's use the last 40 minutes to do some playing in N8N. Huh? There's no better way to learn than having a go at it. So I'm going to come and help you in a second with N8N, but I've got one more resource for you to use. So if you scroll down to the end of the slide deck here, and you go to this resource here, one of the quite cool things about N8N that I think is pretty compelling is that you can easily share workflows, and you can indeed discover and find a lot of workflows on the internet, and simply just click and drag on the workflow. Command A, Command C. Copy it, copy the workflow to the clipboard, and then if we jump into N8N, which everyone should now be in, we can get up and running very, very quickly with a new agent. So how do we do that? So the first thing that we're going to need to do is we're going to click on this plus button up on the top left here, and we're going to say add a workflow. And that's going to give us the workflow canvas or editor. And it's going to give us our first step here. So as we talked about before, the beginning of pretty much every cloud-based workflow requires a trigger. So if we click on first step here, you'll see it gives us a bunch of different trigger events on the right-hand side here that we can select. Many of the ones we've just talked about: on form submission, on web call, on a schedule, on a chat message, etc. Once we have that, we're just going to play with this for a second. So you might just say on chat message. Okay, so on chat message, if you select that, it's going to pop open this settings menu for that particular node. So you can see here we have our, if you cancel out of that, you'll see we have our when chat message received trigger, and then with a trigger itself is of no use. A trigger needs to trigger an action. So if we were to click on the plus button again, you'll see a different set of things that pop up here. And the most interesting ones, of course, are AI. So if you click on AI and you go to AI agent.
Sorry, Chris. On the trigger, like it's a chat trigger. Where is the chat? Where does
I'll show you in a sec. Yeah. So so if you come out of that, what you're going to see is we have our chat trigger here, and you're going to see our AI agent, and you're going to see this little error message. And the error message right now is that we don't have a chat model selected. Now, of course, in order for this AI agent to do anything useful, we need to connect it to a brain. So what we do here is we click on this plus button, and if you scroll down here, you'll see Open Router Chat Model. Okay? If you click on Open Router Chat Model, you should then see this box here, and yours will probably say Create New Credential. Okay? Does everyone have Create New Credential? Yeah? Click on Create New Credential. and you're going to paste your Open Router key into that field. You're going to click save, and it should validate that that key is correct. So the key was the key that we copied earlier, and you should have that. At worst, you should have that in your little Colab notebook here. You can go back and grab it. So you'll want to okay, then you should see that we've got the brain connected there. The next thing we want to do is, well, actually, we can do this incrementally. So let's just start. You'll see at the bottom here, there's a thing that says Open Chat. One thing I didn't mention, I didn't help you load a model, but you can select whichever model you like. I recommend the GPT mini models, 4.1 mini or 4.0 mini for testing purposes. They're very cheap and fast, so I'm going to choose 4.0 mini for mine. And then if I just say hi here and I hit enter, you can see what happens is our little workflow runs. So it receives a chat message, gives us a green tick to say I got the message. Where's it getting the message from? This little test chat widget. It then passed that message that the trigger got into our AI agent. So that's why it's called a workflow. The flow runs from left to right. That's the trigger, that's the action. And what this did was it in turn took the message that we sent in, submitted it to the model, the LLM model that we selected there, and it then got that response, and we got that response out the other end, back down there. Okay, so you just created your own first little AI chatbot. Simplest next step is that we can go back into our Open AI, our Open Router mode here, and we can choose, let's go into our AI agent node. And at the moment, we're just getting a vanilla AI agent. It doesn't have any chops, it doesn't have any capabilities. We're just getting out of the box capabilities. So the first thing we want to do is we want to go, I'll show you how we get there again. Double click on AI agent, and we're going to drop down this add option, and we're going to choose a system message, because we now want to start to test our prompting. We want to give it different prompts and see how it behaves. So I'm just going to edit this slightly. I'm going to say you're a helpful assistant. You only speak in pirate. Okay? Now, if I come back here and I just clear the chat and I go hi, let's see it run. Ahoy there, matey. What be bringing you to these waters today? Okay. If we move this little pane up, what we can do is we can inspect the logs. This is a really valuable way of debugging and understanding what is happening with our workflows. So here we can see that the input was, the system message was, you're a helpful assistant, you only speak in pirate, and the human message was hi, and the output was ahoy there, matey, ER. And I can see that rendered, or if I want to, I can see the JSON, actual JSON information. I can see in the JSON information that there were 22 completion tokens, there were 23 prompt tokens, and there were a total of 45 tokens. Now, the next thing to show you is that if we go back into our AI agent and we just take out the pirate bit and we clear the chat here, and I say, hi, my name is Chris. A very polite AI agent will come back and say, hi, hello Chris, how can I help you today? And if I say, what's my name? you'll see it doesn't know my name. And it doesn't know my name because there's one important thing missing from our AI agent, and that is memory. At the moment, each time we hit the trigger, it's a fresh chat. There's no historical accumulation of the messages that we've previously sent going each time into that chat. So we don't get any memory from the agent. So we need to change that, and we need to add a memory module. So for the memory module, let's click on memory here. You can just select simple memory. And when that pops up, you can change the context window length. What it means by context window length here is how many messages should be stored in the history. So for this one, let's just change it to 10 for argument's sake. And if we go back and we clear our little chat box and we say, hi, my name is Chris. Hi Chris, nice to meet you. How can I assist you today? What is my name? Your name is Chris. How can I help you today, Chris? Okay, so we're getting a different outcome this time because, as you can see, the little green tick here now is this time what happened is after that first interaction, that interaction was saved in memory. So there were two messages, and then when we sent our follow-up, it passed in that initial thing. So when we sent what is my name, it also sent in, hi, my name is Chris. Hi Chris, nice to meet you. How can I assist you today? Then what is my name? And of course, if you pass those in, it knows now that my name is Chris. It's able to answer that question in a way that it wasn't able to answer without the memory. Is that making sense? All right. Now, we have an AI agent with a brain and with memory, but we don't yet have any tools for it to do anything. And this, I think, is the part where you guys can have a little bit of fun and a bit of a play. So you can click on Tool, and here you have access to a range of different tools that you might already be using or have data in. It's not as comprehensive as in terms of the tool integration as some of the other platforms like Zapier, but there's still a hell of a lot there, including Google Slides, Google Drive, Google Docs.
You use your MCP, your Zapier MCP, and then have access to all your.
You can, yeah, you can. So why don't you have a little play now with very simple. We're going to get into much more detail over the next few sessions about how we prompt these things, how we create custom tools, all those different bits. But you can now feel free to scroll through there. Just come up with a simple little workflow that you want to test. Maybe it's connecting into your Notion. So you would add Notion. You're going to need to create a credential for Notion. Creating a credential for Notion. This is where it gets a little bit tricky in N8N, because you've got to basically go, so for example in Notion, again ChatGPT is your friend here. I want to connect Notion to N8N. I need internal integration secret. How do I get that? ChatGPT is very good these days, and in fact, if I'd said use web search, then it would have searched the Notion documentation. But it's pretty much going to link me straight to where I need to go. Open the link. I'm gonna create a new integration here. Give it a name. And I'm just going to follow the instructions that ChatGPT gives me. That's just how we do things these days. So I'm not suggesting you do Notion. I'm simply just showing you that for people who aren't comfortable with where do I get the API tokens and all that kind of stuff, just be patient. Let ChatGPT guide you through the process. What I even would have done there, just a little power tip, was I would have taken a screenshot of that. I said, what do I do here? And I would have gone to ChatGPT and say, drag and drop, what do I do here? So I'm asking it, giving it some visual information so it can help me solve the problem. And it's going to walk me through step by step by step. So is everyone okay to have a little bit of a play with that for now? Things that you can fiddle with, of course, is you can go wild with the system message, which is your sort of prompting. You can again, a power tip here. Let's say I want to create I'll go to ChatGPT and I would say, I'm building an AI agent to work with my emails. Please create a comprehensive system prompt. I use Gmail. ChatGPT is going to give me a pretty decent system prompt that I'll be able to just copy and paste and start tinkering with and test and learn from. So you guys have a little bit of a play with that. I've got a couple of people that probably need help getting on N8N, which I'll quickly help up and then we'll come back to it.
Yeah.
So just a way of thinking about the different workflow platforms. The major ones are Zapier, Make, and N8N. I quite like the way ChatGPT helped me think through this, but you've sort of got this decision lens here. Let's see. And a key thing that is really cool that sets N8N apart is the ability to self-host it. Like for me to be able to throw that on my own server and give everyone access, rather than you all having to go to N8N, sign up for a 14-day trial, blah, 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 blah. That's pretty cool. I've now got to support it, of course. But, Zapier's clear advantage is its integrations with 7,000 apps, Make a few less, and N8N a few less. I think this bottom thing here, non-technical teams, quick prototypes, marketing operations, mid-technical users on Make, and here developers, power users building bespoke AI-rich, privacy-sensitive flows. All of them have a code node, which means that even if it isn't necessarily integrated in the app of your choice, with a little bit of code, you're able to get these things to talk to other servers. N8N has a quite deep MCP integration, which we'll go through next week, which means that you can expose these workflows as MCP servers to, whatever tool of your choice. They're all quite similar. Zapier tends to be very linear. N8N allows, I think, for a bit more complexity in terms of the workflows. I haven't used Make very much, to be honest, so I'm not an expert on that.
Chris, there's another one worth mentioning, Relevance AI.
Relevance, which is an Australian company. Yeah, I think Relevance and Gumloop are two others that sort of, I would say, fall into real premium tooling category, very AI specific, whereas Zapier, Make, and N8N are not AI specific, whereas those are very much built for AI workflows. But the point is, you've got lots of different choices, and this was quite nice because we could throw it up on a server. We can all learn how to use it, but you can transfer a lot of these learnings to the other ones if you prefer. So yeah, have a little play with that. See if you can get something going. Get a simple little agent happening. N8N, what I wanted to show you with the little thing that I set up on the site there where you could copy the workflow, what was that? So what you can do here, because you will find lots of N8N workflows that are embedded on websites just like this. And of course people are trying to sell them these days and so forth. Just Command A, Command C, and then if I go to N8N here and I go to create a new workflow, I can literally just boom, paste that straight in. So if I find workflows that I really like, that others have shared, you'll generally see them, like for example on the N8N website, you'll generally see them embedded like this on websites. Let's see if we can find some lead automation, for example.
You can get ChatGPT to edit workflows.
Yeah, maybe that's worth showing too. So what actually was I copying and pasting there? Let me show you. If I just go to my text editor and I paste it there, there's effectively just a JSON object with an array of nodes here. You can see each node, which describes the triggers and actions. So it's just JSON, which means if it's just JSON, it means ChatGPT, etc., Cursor. They all have been trained on this stuff. They know it pretty well. So you can, if you need help with a workflow, you can just go. So let's say I got stuck here with my with this particular workflow. I would just click and drag, highlight the whole thing. Just make sure, maybe it's Command A. Yeah, Command A, Command C. I'd go to ChatGPT. Let's create a new chat here. I'll say, please explain. And it should know straight away that's an N8N workflow. Okay, it's going to explain it to me. Great way to learn, right? So if you find an interesting workflow, you want to learn how it works, copy it, chuck it in ChatGPT. Please explain to me how this works. Ask question, ask question. Yeah, pretty handy. And you will find tons of these sort of embedded, like if I go to this one here, validate email of, this one, update HubSpot when a new invoice is registered in Stripe. Here we can see there's the workflow. I can click to explore. Copy the whole thing, Command A, Command C. Go back to N8N. Create a new workflow. Paste it straight in. And what this will show you is obviously you're going to need to put your credentials in here. That's what's missing. So this isn't going to work out of the box. I've got to go in. I've got to add credentials for each of those things. And then once I've done that, that's connected to my HubSpot. It's connected to my Slack. It's connected to my Stripe.
So if you sign up with Google to all of these, can that be something that's done instantly? Or when
You mean if you've signed up?
to Google to all of these apps? And you do?
Yeah. Yeah, the apps don't really naturally talk to each other, so you'd have to go and do a, let's look at HubSpot here. The flow is the same generally, which is select a credential, create a credential. If you've already done it, you can just select from the drop-down list. But it's quite nice here, with HubSpot, you've got 3 different ways of integrating. OAuth generally is, trying to think which is the easiest way for non-tech people. Sometimes it's an OAuth where you just click on the link, it opens up the thing. Do you give permission? Yes, I do. Boom, and it adds the credential. Yeah, but ChatGPT is your friend. But this is where I think, you don't end up doing stuff like that in Zapier by comparison. If I wanted to, if I needed to connect something in Zapier, it's generally a little easier for me to do that. Slack, select the app, select an account, connect a new account. Yeah, this is where I think Zapier is a little easier to use in that sense, like connecting accounts and so forth. Zapier much easier to do than in. As you saw there, it was, connect new account, pops up a window. I just grant the thing access and boom, my Slack's connected to it. Although, maybe I should check that here with Slack. So let's say I need to connect to Slack. New credential. It's wanting me to get access to it. It's not as easy. Not as easy to do.
Did you already have it in there?
I already had Slack in there.
Yeah. So once you connect it once, it's all.
Once you're in, you're okay. Yeah. My guidance would be just get ChatGPT to help you with that stuff, step by step. Just be patient. Plenty of people around who can help with that kind of thing. Finding an API token is not hard. Yeah, but look, I think that's...
Zapier also has the Timu version of N8N, which they call Canvas.
The Timu version.
It's not.
Yeah, look, for those of you that are using Claude, I've got quite a cool Zapier little hack. I'll cover this more next week when we get into MCP servers in detail, but Zapier, I think, has a very cool MCP integration. So it's zapier.com /MCP. I can create a new MCP server. My client is going to be, in this instance, it's going to be Claude, let's say. I'm going to create an MCP server. And for this one, I want to give it access to, Slack. This step lists all the potential tools that I might want to give it access to, but I don't want to give it access to all tools. Categorizes it into find data and take action. So for find data, I might just say, find public channel, choose my Slack account. Save that. So at the moment I've just given it one, which is find public channel, and then I'll give it another one. And I'll say take action there should be one to send a message to a channel, send message, send channel message. Okay, I'm just going to give it two tools. Now, what I love about this is very simple. Connect gives me a MCP server URL, which I can just copy here. I can then go to Claude. I opened Claude 2 hours ago. There's a new feature. Deeper answers and more sources. So here, you can see Claude's just launched this thing now, where, just as I said before, ChatGPT, you could say which additional sources you wanted to contribute or allocate to a deep research project. Well, these guys just launched it this morning. So in settings, in Claude, connectors, I'm able to add a custom connector, which you can't do on ChatGPT yet, so this is quite powerful. So I'm going to call this Zapier Slack. I'm going to bang my URL in there. Add that. Connect. And now I should be able to do things like, see if you can see here Zapier Slack, it's got my two tools. Add tools, edit tools, add tools, edit tools. It's not showing me the tools that I do have, but I do have 2 tools in here. Add tools, edit tools. Why is it not seeing my 2 tools? Let's just see. Send message to the Slack AI channel. Say allow once or allow always, allow once. So it's not, see that's buggy. I don't want to use Notion once. Now it's going off on a tangent. Wants to go and search Notion to figure out how to add Slack. Stop.
Did you use Notion? I didn't see you do that.
I added Notion previously, so
Oh, okay.
yeah. But something is not working with I might have done something wrong here. Zapier, connect, select all. We've definitely got our tools in there. Configure, we've definitely got send channel message, and we've definitely got that. That. Connectors, browse. So we should be seeing those 2 tools, and for some reason we're not seeing them. Let's just see what this says.
I think you can only do it in desktop.
Nah, it works for this too. For example, here you can see with my Zapier email, 6 tools are there. Not sure why this was not showing up. What do you know, a tech demo didn't work, but I can assure you it does work, and it works quite nicely. So for the Zapier, what was it, Zapier Notion, I could connect Zapier email, sorry. You can see I've given it access to a variety of Outlook email tasks. I can say, please summarize the recent email I sent about Tokenizer Sprint 3. See, it's making a call to Zapier using this tool, Outlook Find Email. There you go. See, that's pretty handy because a lot of us have a lot of things already connected to our Zapier. So to just expose those as little MCP servers that you can add to Claude, I think it's pretty cool. I don't know why the Slack one didn't work, but working pretty well there, as you can see. Now, I could have that. What's quite cool in Claude and in ChatGPT, of course, is you've got projects. And a pretty cool thing you can do in a project now is, let's just call this test for the moment, is you can actually assign tools to projects. So in a particular project where we can add custom knowledge to this project, so this might be, say, a marketing project where we have a whole bunch of marketing stuff. We have specific system instructions we can add for Claude here about marketing. We can add a bunch of documents. So we could upload, style guides and a range of other things here. And then we could give it specific access. You can see we can switch these tools on and off. We could give it specific access to certain tools. So that way, when I jump into my marketing project here and I start chatting with it, it's got access to the relevant tools, access to the relevant knowledge, and it's got a system prompt that tells it exactly what I want it to do. So it's a very powerful way of using Claude. Now, ChatGPT,
One of the things I like about Claude projects is that Google Drive connects are dynamic. So it will say to you, I see you've updated the file. That's cool. Whereas even Google doesn't have that.
yeah, that's cool.
If you want to update that in chat, last time I looked, you have to go and add it as a new file.
Yeah. So in ChatGPT, here's a project, very simple, very similar. We can add custom instructions, we can add files, but in terms of tools, we're quite limited in terms of what we can allocate to those tools. So we're not able to allocate MCP servers and other third-party tools. So we can't connect from a project into a workflow. Whereas, of course, what we're going to be able to do next week, now that we've sort of got the hang of N8N, and hopefully you'll play with it this week, is you can create your workflows there, and then you can expose them as an MCP server to Claude. Now Claude has access to those workflows, so we could say, hey Claude, can you please do X? And in Claude's little drop-down list here, it'll have access to all the N8N workflows that we've set up and we've exposed to it. Does that make sense? So that's if we go back to that slide I showed earlier, the sort of bridge between this bridge between us working in Claude, let's say, with the tools that it gives us, fantastic. But then being able to bring these, whatever those workflows are that we've set up on N8N or that we have running on Zapier or whatever, be able to include those and have them in projects which are sort of like projects are quasi-agents in Claude and ChatGPT, where they've got specific knowledge, specific prompts, specific tools. Or now, increasingly, this is our starting point for doing all of our work. In fact, if you read that first round article, which I encourage you all to do, Toby bought 3,000 licenses to Cursor, connected them to all of their various apps, and no one goes to those apps anymore. They basically just use Cursor as their entry point. And similarly, over time, you're probably going to be using ChatGPT and Claude as your entry point. You're not really going to be going and fiddling with HubSpot and Airtable and all those things. You're going to be doing it all through there. So now you have all this power. I think the thing I want you to think about for next week, beyond playing with the things that you've got access to this week, think about this, because we should work backwards from this. Like, what are the valuable things that you want to present? And some of you have already shared them. Think about those valuable artifacts and take the time to just sit down and literally sketch out like what goes into creating those artifacts. Because the better you're able to do that, the better we're able to jump into N8N and think about the steps that we'll need to do to produce those artifacts. But that's very much the focus of the sprint. We don't just want to do this for the sake of going, oh, look at all this cool tech. We really want to get you guys to a point where this stuff is producing valuable outputs at the other end. So think about what the most valuable outputs are, and really sort of try to break down, work backwards from them, what goes into producing that particular thing. It might be templates, it might be certain knowledge that's required. Try to articulate that and sketch it out in a flow diagram. And the better you've done that, the better you're going to be able to jump into the workflow tools and automate those bits and pieces. Right, any last questions? I think we have a barbecue upstairs to attend. I know that was a pretty long session and I talked a lot there, but hopefully over the next few, we've got the context out of the way, you've got some tools, you've got an API key to play with, you've got N8N now, you can go and watch some fantastic YouTube videos. The guy you want to follow on YouTube is this guy, Nate Herc. In fact, if you've got nothing else to do tonight, go and watch this particular video. 8 and a half hours of Nate. And he is fantastic. Going through chapter and verse how to use very powerful N8N workflows. To the list here.
You have a QR code to access this slide?
Yeah, I'll show you what it is in a sec.